Well, here is Josh from OpenAI. Welcome. How else do you introduce yourself? What else?
Yeah, I work on a bunch of the thinking models at OpenAI. And like recently I've been sort of focused on doing search related stuff, but yeah, just a post-training researcher at OpenAI.
Yeah, and you were on with us for GPT-4.1 when we were talking with Michelle, who's on maternity leave. I didn't know that. Now we're at 5.1. It's been a whole generation.
Yeah, it's been wild. And like, 4.1 was a non-thinking model. And then since then we sort of switched into doing.
Is that your last? What was your last?
No, we still are releasing non-thinking models. But that one was the one that we did that was like API specific non-thinking. So, focus has shifted a little.
Yeah. How'd you get into post-training?
So previously, before OpenAI, I was doing like pre-training data curation stuff. And I think what I was seeing from like the news and looking at papers is like, oh, it seems like a lot of not pre-training is dead, but I was like, oh, there's going to be so much interesting stuff in post-training. And at that point I was like, I really want to like make some contributions there. And I mean, it's not even necessarily that like pre-training was dead, but it was definitely changing. And like, do I want to make compute efficiency wins of like 3%, or do I want to like change the behavior by 40%? And honestly, it just seemed more exciting to go to post-training. And many late nights later, that's definitely true.
It's a different kind of data and engineering discipline too. It's very strange, like the kind of work that you need in especially RL, like scaling it.
Yeah, definitely. I think like, for example, the number of moving parts in an RL run is just a lot higher. Like in some ways,
you need order of magnitude, or
I don't know if I could do order of magnitude, but if you think about like pre-training, you're moving tokens to many machines, and then you're getting like basically a scalar from them, and then you're backpropping.
Yeah.
The issue with RL is like you're doing tasks, and each task could have like a different grading setup, and each one of those different grading setups, that's like more infrastructure. And so, when I'm staying up late trying to figure out what's going on with a run, it could be in way more things than there's in a pre-training run generally.
Yeah, and does it matter if you own the code of the task, or is it an outsourced third-party person? Or my sense of it and the external sense of it, obviously I don't see it up close, is that you work a lot with external partners, and I'm sure also some internal stuff, but which is better?
Honestly, I don't think I'll comment like too much on like how many external partners.
Well, there are some, and there's some internal.
Yeah, we do like stuff,
but I think the technical trade-off of like, well, shit, like I don't own this code,
okay. So, well, when it comes to I don't own this code, actually, like when I'm babysitting a run or something, it doesn't really matter if it's like internal, external, whatever. Like, do I understand the system that's going underneath? And I think you end up having to like jump into a lot more code that you're like, I actually don't know what this does, because like I'll be watching the, I work on my pieces of a run, and then there's also, other people working on it, and like, do I understand what their code is doing? So that way at like 12:30 in the morning, when I'm like, something looks wrong, and I'm like looking at this code, can I like get context fast enough to understand?
You throw Codex at it?
Wrong. Oh, I use Codex so much. It's really changed how I work. I feel like there's a degree to which like sometimes I feel trapped by Codex, because if I spend like, 30, 40 minutes writing something that looks like a design doc or something, Codex can do more work than I could do in a few hours in like 15 minutes. But then like, what do I do during those 15 minutes after? And like it's actually just like really changed how the flow of my day goes, because I have to somehow now manage these like 40-minute sessions with like 15 minutes where like I could do something, but it's actually not nearly as effective as like this new flow to the day. So I think I'm still getting used to that, honestly.
Yeah. I think it should be interesting for like also just code-based understanding when you're encountering unfamiliar code.
Absolutely.
So you briefly, before we started, talked a little bit about the shopping model, which is like the latest, hottest thing. And obviously we're just recording this right after Black Friday, Cyber Monday. First of all, any interesting findings from basically releasing shopping in ChatGPT right into that period?
Okay, well, I think the first thing is, I don't know like why I would say in a meeting in, August or so, like, oh, hey, Black Friday is coming up. Like maybe we could do a release by then. In hindsight, like, wait, why would I say something like that?
You're like, yes,
yeah.
Now you own it.
Yeah, exactly. I I guess the most interesting thing to me is the new interruptability and like the sort of qualitative experience of using it. And the same thing happens with Codex, right? Like you write a prompt and you can like press escape and say like, oh, I messed something up. And we actually did the same thing in the shopping model. So it shows you its chain of thought with like what products it's looking at. And you can write it new messages saying like, oh, I actually wanted
Didn't mean this. Yeah.
Yeah, like I wanted USB-C on this or whatever it is. And like, I think that's a really new, interesting like interaction paradigm that we have in a couple of our different services. And I'm excited to see how people use it and if they enjoy it.
Yeah. Why did it have to be its own model and not just like a new tool?
Stay tuned. I think like there's no reason that we couldn't do it in the same model eventually, but I think, if we want to try out new things, sometimes it makes sense to make a new model. And I think it just made sense to this time say like, can we do a deep research style model, but like for shopping where it's going to look really hard all across the internet for different things. I think if you look at like deep research, the original one, and GPT-5 thinking on like high reasoning today, I think you'll see that like eventually the models all sort of converge in their capabilities.
Yeah. Would you say that this is a discussion that also a little spicy that I've kicked off in the community? There's still maybe 30% of the community is still using deep research. A lot of them have moved over to just using five thinking as deep research. Is that the spiritual successor? Are they direct replacements? Are there things that we lose in the original deep research model if we do that?
I mean, I think if you look at our published evals, they look like basically on par, if not better. So like, I mean, that's personally what I do. I use like thinking on high versus using the deep research model. But like, I think as we've learned over the past few months, there are sometimes people prefer the quirks of like one model over another. And so if people like the deep research model, more power to them.
People like 4.0. Anything special in the 4.0 post-trading that like, are people like really responding to personality? Is that like a differentiator that people really care about? And you like it's a part of your job to care about personality?
Yeah, I mean, definitely people like care quite a bit about personality. And I think like over the past few months, we've been working a lot on giving users more choice over what personality they want.
Right, which is the toggles.
Yeah. So now we have those toggles.
What's your favorite toggle?
Honestly, custom instruction for like, I personally want my model to like be a tool. And so like, I don't necessarily like want the warmth or anything. I just want some answers because I'm mostly using it at work.
Yeah, so I call this the Anton versus Clippy divide. So Anton is the Silicon Valley HBO.
Okay.
It's a machine. It only does work. It doesn't try to be helpful or friendly or anything. It tries to be helpful, but like doesn't try to be cheery. Whereas Clippy tries to be cheery, and I'm like, well, stop smiling at me. I'm like having a problem. It's like
So it sounds like you also come down on the side of like using
Anton. Yeah. I think a lot of developers want Anton. Right?
Yeah.
They're just like, it just quietly does its work, and when it's done, it shuts up. And
yeah. Well, I think like we're doing a lot of work to provide both like people Antons and Clippies, and I hope they all like it.
Yeah. So just generally, I was thinking about like, well, what can we update people on post-training? What do we know today in NeurIPS 2025 that we didn't know in NeurIPS 2024? I would say like a lot of people at the time, there's still like this whole PPO versus DPO discussion was there. That was a whole era.
Yeah.
And since then, we've moved on to RLVR. And I think a lot of like agents specific RL training. I guess like, am I missing any large chunks of the post-training debates that are going on?
Yeah, I mean, so not necessarily debates internal, but like my read personally from like looking at different papers that are coming out, when you look at like an RLVR paper or like a RLHF paper, they read more like an optimization paper. And to me, like the sort of interesting thing that's going on is we have this like spectrum of how high quality a signal is. So like really at the end of the day, like RLHF, RLVR, they're both policy gradient methods, but what's different is just like the input data. And it's always interesting to me that we call RLHF non-verifiable because we've trained this model to be good at like predicting human feedback. So in some sense, that's like verification. But obviously
it's human preference rather than truth.
Yeah. But like if like your value of truth is like, does the user like this more? Like see, there's something strained that I think we haven't like looked at that axis of, okay, well, how like sort of clean is this signal? How much do I trust it? And like, I totally agree that, you don't necessarily trust the RLHF signal as much as like, is this the solution to this polynomial? But I think there's a whole spectrum of like how high quality is the signal, what's going to happen when I like do a lot of optimization against it. And that's very different than I think worrying about like the variance of different gradients, which I think is what you end up seeing in a lot of the papers that are currently coming out, rather than being like very data centric. They're pretty optimization centric, even though I think the innovation really is where the data is coming from.
Yeah, and before I want to go broad before I go deep.
Yeah.
Any other discussions that maybe you're having in NeurIPS or sort of run about this time on post-training debates? Like what are you meet your peer at Anthropic and DeepMind, and like, what do you talk about?
Well, Anthropic and DeepMind, we're all saying I'm working on stuff and things. You know, we're and I think like it's more so talking a lot more broadly with my friends there, or we're just talking about, man, the infra is so hard to keep up. We're not necessarily talking too much about methods directly,
because on one level it kind of doesn't matter.
Yeah, and I think also like there's something that's very different about academic work where like what really matters is how narrativizable it is, and I think that's one of the reasons you see like a lot of optimization papers come out is a lot of the data work. There's a less clear narrative around it.
I think the data and the scaling is actually more important than the specific.
Yeah, but it doesn't have like necessarily the same narrative that you get out of like some of the papers that you see here, and so like there becomes more of a like, given a specific vertical, how do I like understand that? And I wish there was actually more papers on it here, but I think it can sometimes be harder to wrap up into a clean story.
Yeah, that's also something that like we're actually having a lot of conversations about with other folks as well. Like what's next, right? Like where do you go from here now that we have like some kind of roadmap? I think what's interesting also for me is, I guess, the innovations that are exposed by the Chinese models are maybe copies or like discussions of what's going on in the labs. I think obviously GRPO, when you mentioned like a lot of these RL optimizations, they come out as they present themselves as optimizations. GRPO came out in the DeepSeek Math paper, which when it came out, I read it and I was like, okay, this is kind of cool. It's like a little bit cheaper, but like it does seem to have a more broad impacts, I think, on the industry as a whole than was initially appreciated. And I just want to, I don't feel like we've processed that enough.
Yeah, definitely. I mean, like, yeah, as you said, it came out in the DeepSeek Math paper, and like, it's an interesting optimization method, but it's like the more interesting thing that they have a new reward signal that they sort of like that we can really trust. Like when you find the answer to a math problem, it's a lot less debatable than like, oh well, is this thing that the human preferred actually what we want to do? Yeah, like you want to be right at math.
Yeah.
And so I think in some ways that's underappreciated in, I would say, what's getting published. Yeah.
Yeah. Let's talk about, I guess, long horizon.
Yeah.
What do people consider in terms of like very long horizon? Like we're talking like 30 hours, more than a day of autonomy. Is it just more of the same, or is there anything like sort of qualitatively different?
Okay, so first off, what I would first say is I tend to think more in terms of like actual number of tokens than time, because I think
the human in the loop can take a while.
Yeah, well, and also like it gives you a different measure to optimize against, right? Like as I was saying earlier with when I use Codex, it does something that would take me much longer. It would take me like 4 hours in 10 minutes. What we can actually push on there is token efficiency. So like,
and that is a huge research area.
Yeah, and so you can see like from 5 to 5.1, our overall evals, we bumped some, but if you look at a 2D plot of how many tokens it takes for us to get that, it went way down. And so I think that's like a different.
Sure, when you had that, like, that was such a great chart.
Dude, I live by those charts. Like that, that
was your chart? Okay.
Not necessarily that, but like that shape of chart.
Yeah.
Like I think that's something that we think about a lot, just because it contributes so much to your experience. Like how long does it take to do this task?
Yeah.
And I think the other thing is, as you're pushing that token efficiency, it changes, how many tool calls can I make? And like how many different things can the agent do in a reasonable number of tokens that we can actually serve.
Yeah.
And so I personally think in terms of tokens, yeah.
I think the interesting thing, or the hard to understand thing from the outside, is having an explicit router in GPT-5, but then also basically having an implicit router in terms of the thinking, spending thing. That conflates a little bit, right? Like at some point you do kind of need to merge them, or else you're just going to get these like weird bumps where sometimes the router at the top decides something and it's wrong, and actually if you just handed it to GPT-5, it would have figured it out.
Yeah, and I think, we'll figure out the correct abstractions over time. I think like there's
Is the intention is still to merge? Because that's what it was said in the paper.
Yeah, I think like eventually, we'll have AGI, and like you're not going to have to worry too much about how hard to think directly. It'll just, we'll have one tool that you always go to, and it knows how long to think for and things like that. I think that the abstractions and the way that we drive these things today, it'll change. And like, I think even the amount that we've changed from, having a non-thinking model to you can choose between two, and like, now we can sort of route, and how hard do you want to think? We're adding lots of knobs, and eventually it'll probably simplify.
Yeah, another super interesting knob that everyone is doing is context compaction or memory compaction. What's going on there?
Nothing to share at the moment.
Nothing to share. Yeah. Okay. Clearly an important feature, clearly inspired by Codex usage as well, obviously. But I think like from the engineer's point of view, it feels like I used to do that as part of my harness, and now the model's doing it for me. And I don't know how to think about that, like in terms of, I guess I'm used to having more control, and now I have less.
Yeah, is there a specific like?
There's a specific question. I'm just getting like feedback on like, well, is this a trend that like it's basically a permanent fact of life from here on out?
Oh, I see. I don't know. I worked on long context. That was why I was on last, was for 4.1, where we, I think 10x the effective context window for 4.1. And so there'll always be some dance of like, well, if we want to push as much as what we can do, not only should we increase the length of the context window, but like we should also have strategies for keeping that context window available for as long as possible. I'm guessing that both things will sort of happen, just because we want to put as much power into the models as possible.
Yeah.
Yeah, I think we're still in a period where we should all be expecting changes in the interfaces that all of the models give to us. That way we can improve the models. Because if we lock the interface, I think what would be sad from my perspective is if we lock the interface, if we discover something new about models, we might sort of trap that improvement under an interface that needs to change.
Got it. Talking about long context as well, there is some discussion about, I guess, context rot, or like the utilization of the context. Even if you gave us like 1 million token context, probably wouldn't use all of it. What's the recommendation there? Where are things going? Are we going to have, I guess, perfect context by next year? Is that an impossible dream? I don't know.
No, it's not an impossible dream. I think I'll give a shout out to some of the evals that we did for 4.1 with called graph walks. Where
I love graph walks. We covered this in the podcast.
Yeah, we did. I think if you look over time, all of those evals are still climbing. And I think one of the interesting things about that is you have to do complicated transformations across the entire context window. Like that's sort of the issue with those heat map plots of those different
needle in the haystack.
Yeah, but the problem is if you only have to sample from one point in the context window, it's like sort of easy. Whereas with those graph walks problems, you're having to do multiple transformations across the entire context window. And so I think keep watching those. I think they've been climbing. They'll continue to climb. I would say that that's definitely like a temporary issue that we are climbing on over time.
Yeah. So, and then like, is 10 million tokens realistic? Is 100 million? Like, where is there a natural end, or there's no end and we just are going as far as the eye can see?
Oh gosh, I don't know. Like, what do you think? Yeah.
I feel like, okay, there are use cases that require billions, and there are use cases that require many, many billions, maybe trillions.
Yeah. Out of curiosity, like what would be billions of tokens?
We just had a context engineering discussion about like a RAG code base over support issues for a company, and it was 100,000 documents totaling about 8 billion tokens. You can't stick that in a context window for now.
That's fair. I guess so I would still say like, I don't know, but I think I've been like really surprised. It reminds me of when I was doing like more information retrieval stuff, and like BM25 and these like very simple like n-gram indexes were like just super hard to beat. I think the agents with grep are like, they feel really similar to me, where it's like just unreasonably effective. Yeah.
But then I will not use your 10 million token context window, even if you gave it.
Maybe, but like, what if we're using that context window in service of like some larger goal that just has a lot of sub search calls? Which is why I'm saying like, I just don't know. And I think that's what makes it so exciting.
Yeah. I would say also like the other modalities like video would eat up a lot. And like, then obviously the hard sciences have proteins and all that, which a lot of information just encoded in physics. So I mean, yeah, I'm mixed feelings about it, just because I'm like, well, this will never scale, not with like full attention, and we probably just need to invest in systems anyway, which means we're good with what we have. I mean, like, get your graph walks up, but like, I don't know if we need like 10 100x when actually maybe we need to figure out ways to 1,000 1,000,000x.
Yeah.
Right. Like these are just different slopes.
I mean, I'm glad that you're happy with the current context windows. I think my dream would be to push it and see what happens anyway.
Right.
But
The engineer's incentive is always to say, well, the systems matter more than the models.
Yeah.
And the researcher's incentive is to say, well, screw your systems, or we'll just put the models.
Oh no, it's so differently. Yeah. And I think that's one of the most like sort of beautiful things about post-training at OpenAI is everyone
Co-design.
Yeah, it's also co-designed. Like, you know, I spend a lot of time just doing our system stuff, and I also do lots of stuff like where I'm making graph walks, and I'm like doing a lot more like things on the learning side. And I think it's a great culture to have a place where people just move seamlessly between the two.
Yeah. What are you guys hiring for? Presumably you're hiring. What are you guys hiring for that is hard to hire? What is the skill set that is like, we really need this, can't find it. Please, everyone, go skill up on this.
As my definitely personal opinion here, I think we're still having trouble, not at OpenAI, but I think as a whole, producing lots of people that want to do lots of both systems work and ML work. And I think if you're trying to push the frontier, you don't know which place is currently bottlenecking the frontier, and it changes all the time. I mean, even within one project, it might change multiple times where the current bottleneck is. But I think the education system we have right now isn't really optimized for that. So like I studied math, and then I was very, very lucky to have some like great mentors after school that like taught me to be a good software engineer. But it seems like if we're going to be in this place for a while, and I think we will be, we should probably be producing more students that are great at doing both, you know, distributed systems and like a lot of core engineering, as well as the statistics and other like things that are required to be a good machine learning researcher.
If we were to throw Codex at it, obviously we can't do Codex at everything. That's why still, let's say, like, which will progress faster, which is more solvable by LLM?
That's a spicy question.
You can't say they're both equally hard. I don't know. Maybe they are. I mean, they're differently hard. I think like one is more hill climbable than the other. Which is it? Because then we can go do it.
Okay, I think one thing that's slightly simpler about some of the ML research, like, or you know, ML research is also distributed systems, to be clear. But like some of the things that I would say like get traditionally called ML research are things that you can treat a bit more of as a black box, whereas like, you know, the environment to train on, you know, building these different systems is actually just like a complicated engineering problem. And so theoretically, I would say that they're like probably roughly equal. But I think that there's some amount of effort, I feel like, to making the environments for
But let's say they require they require GPUs in themselves as well.
I guess they both would, but yeah, that would be my guess. But I don't have high confidence in it.
Well, so a lot of people are building this like AI scientists, right? That automates research. You guys have your own benchmark on Paperbench, and that's the one area that, like for example, at Cognition, we've just decided to not do because it's so hard. Okay, any other people on the post-training team that you want to shout out have done like interesting work this year? They should get more attention, but they're not getting credit.
Well, okay, for sure, everyone on the shopping team that I was just working with, so like Andrew Hoyel, Manuka Strada, John Hallman, all great people. Yeah, Issa Fulford, obviously the manager for it.
And she was the original deep research person. Yeah. There was like 3 of them.
Yeah. And so definitely that part of the team. But I mean, everyone is so great. Like I think it's hard to give out a list. It's a really fun time on post training right now. It's exciting every day. Yeah, it feels like we're all enjoying our Diet Cokes together in the office late at night.
Yeah. I did want to squeeze this in before we end. Nobody actually serious is saying that pre-training is dead. It's just a meme. There's a lot of work going on in pre-training. And in fact, actually, a lot of my researcher friends are saying too much money is going to post-training. That's also spicy. I don't know. One of the charts I hold in memory from this year is the Grok 4 chart. I don't know if you've seen it, but it's basically saying, well, we scaled pre-training to here and about the same level of about this level of compute, and now we're spending the same level of compute on post-training as well. That's very controversial, I guess, to me, because like we're all used to post-training taking orders of magnitude less data, compute, whatever, and obviously we're scaling that up now. Do we get to a point where they're equal? I don't know, but it's a topic for conversation. I think how much do we invest in this versus more like different pre-trading?
Yeah,
You've done both.
Yeah. So first off, neither one of those is dead. I think it's really interesting to sort of be living through something that all of my other like historic or technological revolutions are things that I read about in history books, and like
this one's live as it's happening.
Yeah,
you don't know the end yet.
Yeah, and so there's this almost like fog of war where I'm like, oh, did people think that like we got like the steam engine, and they would have, the factories. I don't know if you know this, but like the factories, they used to be like very linear because you had to drive like one motor across an entire room. And it made it so when electricity got developed, they just tried to do the same thing. And they're like, this isn't all that useful. And it took, I think, like a couple of decades before they realized, wait, if we have electricity, we can move the little like stations in whatever is most ergonomic. And then, manufacturing was transformed by electricity. And I think like it really gives me no confidence in being like, oh, this thing is dead.
Yeah, our timelines are so short.
Yeah.
But recently, the way like good ideas get experimented and funded and propagated, actually there's still a human timeline. That's not on AI timeline.
Yeah. And so I think like things will maybe be like dormant, but it'll be spiky. Like there'll be all of a sudden, some whoop. Yeah. And then we'll all feel different. It's like what's the meme? It's so over, we're so back.
Yeah.
It's gonna be that many times. And I think having like some emotional stabilizing to it is probably gonna be good for everyone's sanity.
Yeah, more sanity. Well, thank you so much for joining. Thanks for all the great post-training this year.
Yeah, thank you. And continue giving feedback. I love to hear what you think.
Yeah, awesome.